All right, today we're going to peek under the hood at the engine that's about to power the next generation of artificial intelligence. It's a special piece of custom silicon that Google has been cooking up deep inside its labs. And you know what? It could be a real game changer. So let's dive in.
So here's the fundamental problem facing pretty much everyone in AI right now. The models are getting bigger, the questions we're asking them are way more complex, and the demand for AI it's growing at this absolutely insane exponential rate. And that puts a ton of strain on the hardware that has to do all the heavy lifting.
And the truth is, the general-purpose chips we've been relying on for years, they just can't keep up with this kind of specialized demand anymore. It's like they're hitting a performance wall. To make that next big leap in AI, you can't just buy parts off the shelf. You need something built from the ground up, specifically for this one job.
So what does a custom-built solution even look like? Well, Google's been chipping away at this problem for years, and they've designed a brand new engine specifically for this new era of AI.
See, inside their labs, the same places where they build the infrastructure for the AI we all use every day, they've been doing something really smart. They've been co-designing their hardware and their AI models together. This means they're building the chip and the AI to work in perfect harmony, a kind of synergy that has led them to a brand new piece of silicon.
And they call it Ironwood. That's Amin Vaudat, the head of AI and infrastructure over at Google, and he's holding the 7th generation of their custom tensor processing unit, or TPU. It's a chip designed from day one just for the complex math of AI. But the most important part of what he said is that last bit. This isn't some far-off research project. It's available right now for anyone to use on Google Cloud.
So what's the big deal with Ironwood? What makes it so special? Well, it's not just about brute force, raw power. It's about this whole philosophy of building the chip and the AI model side by side, making sure they work together as efficiently as humanly possible.
And just look at the sheer scale of the improvement here. Compared to their last generation of custom chips, Ironwood delivers 4 times better performance. And that's for both training, building new AI models from scratch, and for inference, which is actually using those models to get answers. That is a massive, massive jump.
Let's just pause on that for a second. A 4 times improvement from one generation to the next. That is the kind of leap you need to keep up with the crazy growth of AI itself. But raw performance? That's only half the story.
In a world where data centers are consuming enormous amounts of energy, just being fast, it isn't good enough anymore. The new question, maybe the more important question, is about how smartly you're using all that power.
And that brings us to this really crucial new way of measuring things, tokens per watt. So think of a token as just a little piece of information an AI is crunching, like a word or even just part of a word. This metric tells you how much actual AI work gets done for every single watt of energy you use. It's really the ultimate measure of efficiency. And this is where Ironwood really, really shines. According to Google, it's not just their most powerful chip ever, it's also their most energy-efficient custom silicon ever. And in a time when the energy footprint of AI is a huge global concern, making this number better is, well, it's a very big deal.
Okay, so we've got this one incredibly powerful and efficient chip. But the real breakthrough, the thing that changes everything, isn't just about what one chip can do. It's about how this one chip builds into something much, much bigger.
Just like Amin Vaudat says, Ironwood is a building block. It's the foundation for what Google is calling their AI Hypercomputer. The goal isn't just to have one powerful chip, it's to have thousands of them, all working together like a single massive brain.
Because with the enormous AI models we have today, the real magic happens at scale. It's all about how you connect these chips together to solve problems that no single processor could ever dream of handling on its own.
And this is what that scale actually looks like. Google can pack over 9,000 Ironwood chips into a single system, what they call a superpod. And you see those pipes running everywhere? That's for liquid cooling, which is absolutely critical to pull all the heat away and keep this beast running at peak performance without, melting. Now, having 9,000 chips is one thing, but getting them to talk to each other fast enough, that's the real engineering masterpiece. Each one of these chips has a ridiculous networking speed of 9.6 terabits per second. That insane amount of bandwidth is what lets thousands of individual processors act like they're one single entity. So here's the bottom line. With that level of scale and that kind of networking speed, you can now run one of the largest, most complicated AI models in the entire world as if it were a single, coordinated job. The system is so huge and so fast that the model doesn't even know it's running on thousands of different little pieces of silicon. Okay, this is all incredibly cool from an engineering perspective, for sure. But what does it actually mean for people who want to, build stuff with AI? What does all this power unlock for us?
So to just wrap it all up, Ironwood and this AI hypercomputer system deliver the raw power and the smart efficiency you need for today's biggest models. But the most important thing to remember is that this isn't some tech from a sci-fi movie. It is available right now for developers and businesses on Google Cloud.
And that, really, is the final most important question. For years, this kind of computing power was locked away in a handful of the world's biggest research labs. Now, it's being opened up to everyone. So the question isn't what's possible anymore. The question is, what are we going to create with it? What will you build with it?